If you've followed my blog for some time, you've probably seen me on what seems like a crusade to merge some microservices back into my Cold Fusion monolith. And I have one more microservice that I want to merge in, but I haven't been able to because it uses Amazon SQS or Simple Queue service. And to date, I don't really have any prior art in terms of consuming an SQS queue within my Cold Fusion application. So I wanted to start digging into Amazon SQS and seeing how I might be able to use it inside my Cold Fusion application such that I could forge a path for merging this microservice back into the monolith. So as an introductory hello world, I wanted to just see if I could produce messages or push messages onto that queue and then read them from the queue. So let's just go ahead and preload a few messages, A, B, C, D, E, F. And now let's start polling for those messages. So we have A shows up and then refresh, C, so you'll see that they don't necessarily come in order. Then we get E, F, D, B. All right, so now we can start. So this is now polling in the background. So we could say, hello there. And you can see that immediately became available in my consumer. What it'd be like. There we go. Foobar Baz. So you can see that we can produce messages onto our Amazon SQS queue and then quickly show those using our long polling technique on this side. So now that we see what we're trying to do, let's take a look at the mechanics. As with previous Java integration explorations, what I'm going to do is create a Cold Fusion component that simply provides a load method as a way to hide how we're actually pulling those Java classes out of our system. In this case, I have a vendors folder and I'm going to create a collection of jar paths, which then can be used inside our native create object calls. So I can pass in a class name to this load method. I'm going to load that class out of these jar files. And now my SQS client doesn't actually need to know where it's getting all the classes from. It just has to know that it receives this class loader, and this class loader hides those implementation details. So once we have this Java loader, we can look at our SQS client. Now, the SQS API isn't super huge, but it's more complex than what we actually need to do inside of this demo. So what I want to do is create a client that is geared towards the simplicity of this demo. And so it will expose methods that are similarly simplistic, which means that all we have is essentially some CRUD methods. We have, let's see, we have our send message, which is essentially our create. We have our receive messages, which is our read, and our delete messages, which is our delete method. And that's all that is exposed by this SQS client. Again, the goal of this client is to do two things. One, hide some of the complexity around the low-level Java integration, but then also create a simplified API geared towards this particular demo and use case. So you'll see in our SQS client constructor, I take the class loader, and that is the component that we just looked at that hides the jar file implementation. We're going to then use that class loader to build up our credentials and our actually underlying SQS client, which is the Amazon SQS client builder. You can see we're going to use standard builder, and then we're going to provide credentials for this particular region, and then we're going to build. And that gives us our SQS client that is tied to these credentials and this region. Now you'll see that I'm also passing in a queue name as part of this constructor. So the intent here is that I want to couple the actual queue to an instance of my SQS client component. That way, again, I can simplify my API. I don't have to pass in the queue name every time I invoke a method because the queue name here is baked into the state of the component itself. Again, the goal here is to create an abstraction that makes consuming the queue easier, not simply as verbose as dealing with the underlying Java client. So if we look at something like the send messages, again, we just dip down into that class loader, we load our classes, we initialize with the baked-in queue name, the message, which is just a string, set some attributes, send it. On the receive, we go out to the queue, we tell it how many messages we want to receive, and that is a max, not a absolute number. And then we receive messages here using this wait time. This wait time is going to implement a long polling, and that's why we see here in our demo, if I just say hey there, it will instantly show up, because in the background, this consumer is actually sitting there in long polling. In fact, if we open up the Chrome DevTools and we look at the network activity, let's just do test. And what you can see under the hood, oops, this one of them, let's see. Why is that not expanded? There. So this is just sitting here polling for up to 20 seconds. And if we then do test, you'll see that gets killed, and then we get an automatic refresh, which then starts to poll again. And then eventually that returns with some collection of messages, and then we're just going to map it onto something that we can use locally. And then delete messages is super easy. So the actual low-level mechanics of interacting with the queue are actually fairly straightforward. You can dig through this. It's basically just, again, a simplified wrapper around the Java SDK that Amazon ships for its products. So the produce page, let's get rid of this again. So the produce page, this top frame, this is just a frame set here. So this top frame is going to be super simple. All we have is our form field with our single input called message text. And when that form gets submitted, you see we have our SQS client calling send message. Send message takes a string. In this case, we're going to represent that string, or we're going to use that string to encode a JSON payload, a JavaScript object notation payload. And then here we can pass in an additional struct of attributes. These are attributes that can just be read out when we receive the message as well. It's sort of metadata that allows us to pre-process or file or collate the message before we actually parse it, should we need to. On the consume side, it's again slightly more complicated because we're dealing with long polling. But essentially, if we jump down here to the default page, you can see when I hit start poll for messages, all that does is refresh the page with poll equals true. And if we look at the poll equals true up here, all we do is we go down to the SQS client, we receive messages. We're going to tell it to get a maximum of 3 messages at a time. We're going to tell it to sit and long poll for up to 20 seconds. That's the max allowed by Amazon SQS. And we're going to use a visibility timeout of 60 seconds. That's mostly irrelevant for this particular demo. But what that means is that when we receive a message, Amazon is going to hide that message from other consumers for up to 60 seconds until we tell Amazon SQS that we've processed it. And that's what that delete message is. So every time we get a message, Amazon puts it into this sort of hidden pending state. We then process it within our business logic. In this case, that just means pushing it onto this array in memory and then dumping it out to the page. And then we have to tell Amazon that we have successfully processed this message and it should delete that message, instead of after the visibility timeout finishes, it'll put it back into the queue should we not explicitly delete it. And there we go. And that's all there is to it. So the mechanics, we can stop polling here. So the mechanics of actually interacting with an Amazon SQS queue are fairly straightforward, especially when you use the Java SDK under the hood. We're really just creating a light wrapper around that SDK. It's going to be actually taking this queue and interacting with it over the life cycle of an application. That's where I think a lot of the complexity is going to come from, but I'm not there yet. But hopefully that will be fodder for some follow-up blog posts.